Hey everyone, and thanks for watching today's video where we're going to go through some practice with arc length and sector area. So this is we've had the introduction videos and we've gone through a few simple examples of each one. Now we're really going to combine the two and make sure you understand the differences and the similarities between them. So quick refresher on the formulas. So for arc length, we're looking for the length around a certain measurement. So let's say we have this arc here. We're looking for the measure around a certain arc. So we have this here. Arc, let's name it AB or something. The arc length is the perimeter from A to B. So that's arc length. And sector area is the area inside of the arc. So sector area is the area right here. So it's very similar to kind of the area versus perimeter problem that you've gone over countless times before. So in the side, we have sector area. And the good thing is that the way you calculate them is almost the same. So we figure out what portion of the entire circle the angle covers. So if this angle was 90, it would be 1/4 because the entire circle is 360. So we take the measure of the central angle divided by 360 for both formulas for arc length and sector area. And then we multiply by the entire circle's either area or length. So remember, the entire circle's length, the circumference, the perimeter of the entire circle is 2 pi r. So C equals 2 pi r. And remember that this also equals pi d, where d is diameter. And then the area, for sector area, we're just going to multiply by the entire area of the full circle. So we take the part that we're looking for and multiply by the entire circle's area, and that's pi r squared, and this is the area formula. So hopefully that makes sense, and hopefully now we can get into some practice questions. Okay, so the first one we have is find the area of each sector and the length of each arc. Okay, so sector BAC and arc BC. I didn't talk about this last video, but with sectors you do want to put the entire sector, so you would want to say BAC, so that kind of makes it obvious that you're going to point A and then back to C instead of sector BC, just because if you're doing the entire sector, so you need to include that central angle. That was my bad in the last video, but we got it now. Okay, and arc BC. So let's just use our formulas. So sector BAC's area is going to be, well, it's going to be the angle measurement divided by 360. So 40 divided by 360. Then I'm going to multiply by the area formula, which is pi times r squared. And r I'm given is 9. So 9 squared. And I'll simplify that. So 40 divided by 360 is going to be 1 divided by 9, I believe, times 81 pi, just 9 squared. And that's going to simplify to 81 divided by 9 pi, which is just 9 pi. So that is the area of our sector BAC. And now let's think of arc length of BC. So again, really similar formula. We have 40 divided by 360 again. The only difference now is that we multiply by the circumference instead of the area. Circumference is 2 times pi times r. And that's going to simplify to 1 divided by 9 again. Now it's going to be multiplied by 18 pi, which equals just a 2 pi. And that's it. So the length of the arc BC is 2 pi, and the sector BAC has an area of 9 pi. So this area inside is 9 pi. All right, so on to the next one. Find each arc length and sector area. Okay, so we're looking for sector XYZ. Y is the point in the middle, by the way. So sector XYZ and arc YZ. Okay, so now we're not actually given the sector. We kind of have to make it ourselves, and we're not given the radius, I notice as well. So a few things that we're going to have to do here. Okay, so sector XYZ. I'm going to draw on my sector here, connect these lines, see what I'm dealing with. Okay, that looks better. And now a key here is that we're given the outside angle. That means the inside angle is also 80 degrees. So good thing to just write in, get in the habit of doing that. Okay, and now also we're given the diameter. We're given the diameter is 16. Remember, diameter is from endpoint to endpoint. Radius is always half of that. So the radius is going to be 8, which means that these are all 8s here, which is important. So radius, which equals 2 times the radius, so r equals 8. Okay, and now I think I have what I need. I'm given the angle measurement. I have the radius now. I think I'm good to go. So I'm going to look at sector XYZ. That's going to be the angle measurement divided by 360, so 80 over 360. Multiplied by the area formula. Area for the entire circle is going to be pi r squared, which is 8 squared times pi, because the radius is 8. And then that will leave me with, well, 80 divided by 360 is 2 divided by 9. times 64 pi. And that can simplify to 128 divided by 9. 128 pi divided by 9. And I don't think that can be simplified anymore. So we're going to leave it as that for now. Actually, it probably can be. Nope, it can't. Okay. So we're going to leave that as the sector area. Okay, so now let's think about arc length. So arc YZ has to equal, well, 80 divided by 360 again. And now we're going to multiply by the circumference instead of the area. Circumference is 2 pi r or pi d. So that's going to be 16 pi. And that's going to simplify to 80 divided by 360 is 2 divided by 9 times 16 pi. It's going to give us 32 pi over 9. And again, that one can't be simplified. So that's going to be the sector length, the arc length, while we have the sector area of 128 pi over 9. So inside here is 128 pi over 9. And the arc length, so that length from x to z, is 32 pi over 9. All right, so we got one last one for us to work out here. Find the area and area of sector KJL and the area of triangle KJL. So this is a little bit different. This is a challenging one. I recommend you pause here, see if you can figure this one out on your own, and then watch what I do and see if it matches up. So first I'm going to figure out the area of sector KJL. That's something we've been doing a lot now. We've got that formula down. So what it is it's the angle measurement divided by 360 times the area formula, which is pi times r squared, so pi times 10 squared, equals 1/4 times 100 pi. And that just simplifies to 25 pi, because that's 100 divided by 4. So I found area of sector KJL pretty easily, but what does it mean when it says find the area of triangle KJL? How do I do that? So triangle KJL, well, that means that K and L have to be touching, or have to have a segment connecting them. So I'm looking for this area here. And I also see that we have a right triangle, right? It's a 90 degree. So yeah, it's a right triangle. So that means that it has a hypotenuse, which means I can apply the all-important Pythagorean theorem here. So if I wanted to find the last side, I could do that, but I don't need to do that necessarily, because what's the formula for area of a triangle? Well, 1/2 base times height equals area of triangle. And I'm given side JK, but I'm not given side JL. How do I figure out JL? Well, it's just going to be another radius. It has to be another radius because that's the definition of our arc, is that it has two radii going together. So JK forms a radius and JL forms a radius, and we know that the radius is 10, so that's 10. And now let's think about our triangle. Well, we have a right triangle here, so the hypotenuse is here. Knowing that that's the hypotenuse, we know that these two are the base and the height. The 10 and the 10 have to be the base times height, because this is our triangle basically. Here, here, here would be another way to draw the same triangle with 10, 10. So the area is going to be 1/2 base times height, which is 1/2 times 10 times 10, which equals 100 divided by 2, which is going to be 50. Okay, so now what if they wanted to, a common question is now, well, what is this area here? They'll highlight this area and ask you, well, what is that area? That's a good question, because you have to be able to find the measurement of the entire sector and then the measurement of the triangle within the sector, and then you subtract them. So it would be 25 pi divided by minus 50 would be the angle of this guy right here. But the area of the triangle is 50. I just want to make it to where if anyone fast forwards, they can still get the right answer. Area of the sector is 25 pi. And the area in between the triangle and the sector, so this little area right here, is 25 pi divided minus 50. And we could use a bunch of simplifying mechanisms for that and try to get it a little bit easier, but we won't do that here. We'll just assume that this is good enough. So hopefully that makes sense. Hopefully now you really understand arc length and sector area. Two intuitive formulas, and they're useful. They're used in a lot of different ways, and so hopefully you understand them by now. And don't hesitate to contact me with any questions. Thanks for watching.